Hey everyone, I'm Dr. Surjit Singh. In this video on Python via examples, I'll talk about the tuple data type and its applications. Let us begin. In this session, we'll discuss about the tuple data type that is ordered and non-mutable and about its unpacking. We'll talk about their conversion to lists and back. We'll discuss zipping and its use in finding the transpose of a matrix. We'll also talk about swapping and two sorting methods. Tuples are like records that are defined using a template. Tuples form a non-mutable ordered data type. We define a tuple variable named planet. It represents the first planet of the solar system whose name is Mercury and radius is 4880 km. We express the items of a tuple within parentheses. When we save the information of other planets in a list of tuples, we must store their information in the same order of items for all the tuples. We can print a tuple and its type. Tuple is iterable, so we can process its items one by one. Tuple is an ordered data, so we can refer to its data items by their indices. Print statements give these lines. However, we cannot change the value of an item of a tuple because tuple is not a mutable data type, nor can we increase the number of items of a tuple. Unpacking means extracting items of a tuple in different variables. These three lines of previous program can be written together in a single statement like this. Items separated by commas become tuple even if they are not enclosed within parentheses. Even the definition of the planet can be written without parentheses. These statements are used for packing and unpacking of the items of a tuple. Here the list named triangle has a list of three tuples. Each of them represent the vertex of a triangle. The two items of each tuple represent x and y coordinates in the same order. Let us pick the point at index 1 of the triangle by saving it to P, for which x coordinate is P0 and y coordinate is P1. We can also combine these two lines as this. Here pth point of the triangle unpacks to x and y coordinates. Let us print these coordinates. P equal to 0 gives the starting point of the triangle and P equal to -1 gives its last point. We can convert a tuple to a list and vice versa. Consider an example in which list of the dimensions of a box are 5, 3 and 2 feet. We print it. Tuple function converts a list to a tuple. We print the tuple also. Likewise, list function converts a tuple to a list. MyList is a list of x items for which x lies in a given range shown in the program. To begin with, MyList is empty. Range function is an iterator which gives first value as 4 to x. We add it to list. Increment is 3, so next value of x is 7. We append this also to list. The process continues as long as x is less than 25 and for loop terminates when x is 25 or more. We can print MyList. Zipping means combining data items to form tuples. We are given articles and their costs in two separate lists. We can use zip function to obtain an iterator that joins the items of the two or more lists and use it in a for statement. The loop variable in each iteration will be a tuple that will get one item from each list. Process stops when one of the lists exhausts. First tuple is pen and 10. Next iteration links pencil with 3 and third iteration gives the tuple ink and 5. Cost of folder is not known, so the iterations end here without processing folder. Alternatively, we can save these tuples in a list. Right side forms the list of articles for articles present in the iterator, which can be simplified in this way, in which we convert zipped iterator to a list. We can further combine the two statements into one. Rate list is the list of zipped tuples of articles and costs. We shall now discuss about transpose of a matrix. It is a tricky process, so follow it carefully. Mat is a list of three tuples. Star mat extracts three tuples of the list for zipping. Items at index 0 of three tuples are 1, 4 and 7, and on zipping them we get first tuple of the iterator. Next items of three tuples give 2, 5 and 8. Their last items give the third tuple of the iterator. With this, the zipping process is complete. Transpose definition starts with an empty list. We will now enclose x in this list. For loop supplies values of x. In the first iteration, x is the tuple 147. We enclose it in the list. In the next iteration of the for loop, x is 258 and we put this also in the list. Third iteration of for loop appends the tuple 369 to the list. With this, the for loop ends and we get the final list transpose. Let us print the rows of the original mat and its transpose. In transpose, rows and columns interchange. Once again, we can simplify the expression of transpose like this. Enumeration means zipping of the index with the item. Length of the list is 3, so range produces the sequence 0, 1 and 2. We use serial number plus 1 in the print function to get 1, 2, 3 as the serial number in the output. We can get same output by using enumerate function. Enumerate zips the index of an item with it and we receive a tuple in each iteration. The tuple then unpacks to give serial number and name. We print them for each iteration. If we want that serial number starts from a value other than 0, we give the starting value as the second parameter in the enumerate function. Swapping the contents of variables is very important and is employed often in programming. To begin with, we are given a is equal to 4 and b equal to 5. Our aim is to interchange their values. If we write a equal to b and b equal to a, it does not help because it gives 5, 5 as the output. The reason for this is simple. A equal to b causes this. Both a and b become 5 while 4 becomes garbage. It is therefore essential to save 4 before assigning a equal to b. So we revise the program by inserting the line temp equal to a that saves 4 in temp. Now a is equal to b x as shown. This time 4 is not dangling. Lastly, b equal to temp gives the desired result. Print AB now gives 5 and 4. This is the standard method for swapping two numbers in all programming languages. But Python has a shortcut method. This single line replaces three statements of swapping. In this, tuple BA replaces tuple AB in one step, so there is no need to involve a temporary variable. Bubble sort is a famous method for sorting a list. We are given list A for sorting. It has 6 items, so index of last item is 5. Remember the school time when all students assemble in a queue. To get the smallest boy in front of the queue, you swap position with a taller boy in front of you. One round of swaps is not enough. It only brings the smallest boy in the front. We repeat the process for every position. In a loop, I takes values from 0 to 4. When these positions are set, last position automatically has the tallest boy. I starts with 0. In a loop, j starts with the last index and decreases as long as it is greater than I. We compare the item there with its previous item. 6 is greater than 2, so we swap them. In the next iteration of j, we find that 1 and 2 are already in order. We skip the if statement. In the next iteration, we compare 8 with 1 and swap them. In the next iteration of j, we swap 3 and 1, and in the last iteration of j, we swap 7 and 1. All iterations of j are over. We come out of the loop over j and print the current status of the list. The list is much better sorted and position I has got the lowest item. For the remaining list, we increase I by 1. This time 2 and 6 are already in order. But we swap 8 with 2 and then 3 with 2 and then 7 with 2. Loop over j ends. Current status again shows that position I is sorted. In the next iteration of I, the two swaps are 8 with 6 and then 7 with 3, after which we check the current status. In the next iteration of I, there is only one swap, that is between 7 and 6. The list is now fully sorted, but we cannot take a chance and carry out all iterations of I even when there is no swap. Last index minus 1 is the final iteration of I, so both the loops end. Bubble sort is a simple algorithm, but it involves too many swaps and is therefore not the best. Selection sort is a modification of bubble sort. It makes only one exchange in each iteration. Consider the same list. In a loop, I covers all items of A. To begin with, I is 0. We shall find the position of the minimum item from I to end. To begin with, we assume it to be I, where item is 7. We will shift minimum pose if an item less than 7 is found. So we start a loop over j from I plus 1 to end. Starting value of j is 1. Item at j is 3, which is less than 7, so we mark it as the new minimum pose. Further comparisons will be with the item at this pose, which is 3. Next value of j is 2. At 8, it is not less than 3, we skip the if statement. Now j becomes 3, where item is 1. As 1 is less than 3, so it becomes the new minimum pose. Further comparisons will be with 1. Neither 6 nor 2 is less than 1, so we do not shift the minimum pose. Loop over j ends. We have found that 1 is the minimum item and its position is 3. We bring it to the position of I by swapping the items at minimum pose and I. We print the list again to know about the changes. In the next iteration, I becomes 1. We fix this as the starting minimum pose of this iteration for which item is 3. We compare subsequent items with 3. For this, we start the loop over j from I plus 1 onwards. We skip the if statement for j equal to 2, 3 and 4. However, when j becomes 5, an item less than 3 is found. So, minimum position becomes 5. Loop over j ends. We swap items at positions 1 and 5 and print again. I becomes 2. Minimum item between positions 2 and 5 is 3. We swap 8 with 3 and print. In the next iteration, I is 3 and minimum position is 4. We swap 7 and 6 and print. When I is 4, the minimum position is also 4. So we exchange the item 7 with itself. Same is true for the last iteration. In this session, we discussed about tuples and their unpacking, conversion of tuple to list and back, zipping, transport, and enumeration. We also discussed about swapping of two variables and about bubble and selection sort methods. I hope you liked the video. Thank you for your time. Please feel free to ask for further clarifications on my email address given below. I'm looking forward to your comments. Please stay tuned for more.